Prove that x plus 9 divided by x plus 2 is greater than or equal to 4, where x plus 2 is greater than 0. Now, I've written down this inequality here. I'm going to just write it down as if it is true for x plus 2 greater than 0. By the way, if x plus 2 is greater than 0, it means that x must be greater than minus 2. So we're really only going to prove that this inequality is true for values of x that are greater than minus 2. Just follows from this here. Now, we want to get this inequality into a straight line. What do? Well, we want to cancel this x plus 2. Since we're given that x plus 2 is greater than 0, we can just multiply both sides of this inequality by x plus 2. We don't have to consider the other case. The other case is where x plus 2 is less than 0. So multiply both sides by x plus 2. We've x plus 2 by x. We've x plus 2 by 9 over x plus 2. That gives 9. And then we have 4 times x plus 2. And since we're multiplying both sides by something that's positive, this greater than symbol remains a greater than symbol. So we want to show that this thing here is true for values of x greater than minus 2. Now we simplify down both sides. We get x squared plus 2x on the left hand side. I bring the 4x over. 2x minus 4x is minus 2x. We have a plus 9. We have a plus 8 on the right hand side. 9 minus 8 is 1. So we get it into standard form. We want 0 on the right hand side. So this is the standard form for a quadratic inequality. So we want to show that this is true for x greater than minus 2. Now let's see for what values of x this inequality is true. And hopefully those values of x are greater than minus 2. Well, actually, we want to look at values of x that are greater than minus 2 and see if they satisfy this inequality. So I'll just work with this inequality. So the first thing you do is look at the quadratic equation. You solve this quadratic equation to get its roots. So the roots are minus b is 2 plus or minus the square root of minus 2 squared, which is 4, minus 4 times 1. We end up getting 4 minus 4 in here. We end up getting 0 in here. And we divide by 2 times 1, which is 2. So we get just a single root, 2 divided by 2, which is 1. So there's only one solution to this quadratic equation. So really all you have to look at is b squared minus 4ac. That's the discriminant. That's what's in here. If that's equal to 0, it means we only have one solution. We look at a graph of y equals x squared minus 2x plus 1, and that will tell us straight away for what values of x y is greater than or equal to 0. Now we know that there's only one solution, and that's at x equals 1, so the graph must cross the x-axis at x equals 1. Furthermore, we know that the x squared term is positive, which means that the u-shape is upright. So the graph must look like this, crossing at x equals 1. Of course, it goes on forever here, but arrows here. So you can see that for all values of x greater than minus 2, well, minus 2 is somewhere over here. You can see that for any value of x greater than minus 2, the value of y will be greater than 0. Like if we take this value here, which is greater than minus 2, and go up to the curve, we get a value of y that's greater than 0. This value of y is positive. Indeed, if we take any value, if we take x equals 1, we'll get y equals 0. But that's allowed, because y can be greater than or equal to 0. As a matter of fact, y is only equal to 0 for this one value. For all other values of x greater than minus 2, y will be greater than 0. So now you see that this inequality is indeed true for values of x greater than minus 2. So we could just reverse our steps. We could reverse back to this step and then go all the way back to this step, which means that we've shown that x plus 9 over x plus 2 is greater than or equal to 4 for x plus 2 greater than 0. In part 2, we want to prove that x plus 9 over x plus a is greater than or equal to 6 minus a for x plus a greater than 0. Well, x plus a greater than 0 means that x must be greater than minus a. As a matter of fact, the inequality in part 1 is a special case of the inequality in part 2. if we plug in a equals 2 in this inequality, we will get the inequality in part 1. Now, since we're given that x plus a is greater than 0, we can multiply both sides of this inequality by x plus a. So that means we can cancel this denominator. So this is what we get. X plus a times x plus 9 is greater than or equal to 6 minus a multiplied by x plus a. Now we can get this into the standard form of a quadratic inequality with 0 on the right hand side. Of course, the symbol here retains its direction because we multiply both sides by something positive. So I've just multiplied out the left hand side. X squared plus ax plus 9 is greater than or equal to 6 times x plus 6 times a minus ax minus a squared. So I'm assuming that this is true, and we hopefully will deduce something that we know for a fact is true, and then we can just simply reverse all our steps. Now we want to get this inequality into the standard form of a quadratic inequality. That means we want 0 on the right hand side. So we have an x squared term. Now to get the x term, we have ax here combined with minus ax. Bring that over, that becomes 2ax. We also have a minus 6x. So we have 2ax minus 6x. I factorize out this x. See, we want to prove that this inequality is true for all values of x that are greater than minus a. So we want this to be a quadratic inequality in x. So we have our x squared term, we have our x term. Now the constant term is going to not involve x. So all terms that do not contain x. So that's plus 9, bring over the plus 6a and bring over the minus a squared. So this is the constant term in our quadratic inequality. This here is b, the coefficient of x, and a is 1. Now, as you saw for the previous part, for this quadratic inequality to be true for all values of x greater than some value, doesn't actually matter, we want the solution to the quadratic equation to have only one root. We just want only one solution to this quadratic equation. So if we look at the quadratic equation, which is x squared plus 2a minus 6 times x plus 9 minus 6a plus a squared equals 0. So here is the quadratic equation. I've just written this out again, just an equal sign. So for one solution, we must have that b squared minus 4ac equals 0. So all we've got to do is show that this is 0. That means that if we were to draw the graph of y equals this quadratic here, we would see that it's above the x-axis but touches the x-axis at just one point. And that point would be the solution. That point would be the value of x that makes this inequality an equality. Just the one value where we get that this expression is equal to 0. And for all other values of x, y will be positive. Y will be greater than 0. Like if we take this value here or any value, we'll see that y is greater than 0. So we know it's an upright u-shape because the coefficient of x squared is positive. So we expand this out. 2a times 2a is 4a squared. 2a by minus 6 is minus 12a. Double that, we get minus 24a. Minus 6 squared is plus 36. We multiply minus 4 into this, and you can see that it all breaks down to 0. So we're finished the question now, but if you want to go one step further and actually get the root of this quadratic equation, all you have to do is use your minus b formula. It's minus b plus or minus the square root of b squared minus 4ac all over 2 times a, where a is 1. Well, of course, b squared minus 4ac is 0. So we just have plus or minus 0, so we just get one root. We get minus b over 2. That's minus 2a plus 3 over 2, or minus a plus 3. And that's the root there. And you can see that for all values of x that are greater than minus a, then our quadratic is above the x-axis. It touches it at just one value. So at x equals minus a plus 3, we will find that this expression is identically 0. So now that we know that this is true for all values of x greater than minus a, then we can reverse our steps and prove our original inequality is true for x greater than minus a.